Okay, with question 19, at the top of the page for both of these, I've put on where on Maths Genie you can find the bits that will help you with this, because trig graphs goes right back to year 10. We haven't really looked at it this year, so if you've forgotten everything on that, we could do with revising it in class, but in the meantime, go to the Maths Genie website, grade 7, and there's a topic that's called harder graphs, trig and exponential. This is a trig graph. So your trig graphs are y equals sine x, y equals cos x, and y equals tan x. They are your trig graphs. So y equals cos x, you really just have to remember these. The cos x graph goes between 1 and minus 1. It's a sketch which indicates that it should be accurate, but it doesn't have to be perfect. The cos x graph is the one that starts at 1 and it curls down to 90 at 0. It curls down to 180 minus 1, and then it comes back up again. So if you go and look this over, it's also worth trying to memorize what the sine x graph in particular looks like, and the tan x graph if you've got time. But that is the graph of y equals cos x. It's something that you just have to remember, really, rather than being that mathematical at the moment. And then the transforming graphs, again, I've put at the top grade 8 and 9 on Maths Genie. There's a topic called transforming graphs y equals f of x that has a video and some questions. And the bits that you need to know are for your GCSE are translations, and reflections. Now, the first one, part 1, is a reflection. So if I just do a bit of a talk about reflection here. When you have a reflection, you will either have y equals minus f of x or y equals f of minus x. Now with reflections, there's only two types. There's reflection in the x-axis and reflection in the y-axis. So you just have to remember which one of these is a reflection in the x-axis and which one is a reflection in the y-axis. A cheat way of remembering it is that with this one, the minus sign is kind of inside. We say it's the interior of the function. Whereas on this one, the minus sign is outside, it's on the exterior. If the minus sign is exterior to the function, then it is a reflection in the x-axis. So exterior, x-axis. Interior, by a process of elimination, is a reflection in the y-axis. So in this case, the minus sign is exterior. We are reflecting it in the x-axis. So I should really use a ruler. If I reflect this in the x-axis, that line now comes down here. That point is now going to be at minus 3 instead of 3, so it's going to come down here. That point is now there. I've reflected it in the x-axis. And then this line will come across like that. So I've reflected the graph in the x-axis because the minus sign is exterior to the function. If the minus sign was inside and we were reflecting it in the y-axis, well, actually for this shape, reflecting it in the y-axis, you'd actually end up with the exact same graph. So that's maybe a clue. As well as it being exterior here, in this case that's maybe a clue that it's a reflection in the x-axis. Because if you reflect it in the y-axis, it ends up on top of itself. It's the exact same thing. So the translations, there's two types really. Because there's a bit of space, I'll discuss them down here. There's ones where you've got f of x like plus 4 or f of x like minus 2, where you've got a number after the f of x, and that is a translation up or down. So this f of x plus 4 means you'd be moving the whole graph up by 4. And f of x with a minus 2 outside it is where you move the whole graph down by 2. So it's kind of what you'd expect. A plus 4 moves it up 4 and a minus 2 moves it down 2. Whereas when you've got like a plus or a minus, like x minus 3 or x plus 7 or whatever, inside the brackets, inside the function, this is a movement in the x direction, and this is where it gets a little bit confusing, because whereas this is like 4 up and 2 down, the movements in the x direction are actually counterintuitive. F of x minus 3 actually moves it 3 to the, people would be expecting left, but that actually moves it 3 to the right. And like if you have f of x plus 5, that would actually move it 5 to the left. So if I write this up next to it, this first one would move the graph 4 up, and this one would move it 2 down. So the numbers outside the f of x bit move it up and down, and it's kind of the way you'd expect. This, when you've got numbers inside, x plus 5 actually moves it 5 to the left, not really what you'd expect, and x minus 3 moves it 3 to the right. So I need to move this whole graph 3 units to the right. So this point, 1, 2, 3, will now be there. So it starts there and it comes across 1, and then it goes up. So this point is now going to be 3 units to the right, which brings it over here. Try and keep this accurate if I can. This point now moves 3 units to the right, 1, 2, 3, which moves it there. And then I've just got this little line at the end. So the whole graph has been moved 3 units to the right. Again, if you want to practice this transforming functions and these rules, translations as well as reflections, which we discussed up here, then just remember the Maths Genie. It's grade 8 and 9, and it's transforming graphs y equals f of x. So for this bit and for this bit, on the website they've got videos explaining it, and they've got questions for you to try, and they've got the answers that go with it. So if you're confused by either of these, I really would recommend taking the time to go to Maths Genie and practice it when you've got time.